So we have three kinds of special parallelograms. So let's go ahead and box that. The first one is a rhombus, then we have a rectangle, and then a square. The reason it's a special parallelogram is because these three figures have all the properties that a parallelogram has, okay? So the first one, let's see. I like to think of the rectangle as a parallelogram with, oh, that's not very pretty. With, all right. Okay, give me two hands, hands up. Let's start with the parallelogram. From this parallelogram, if I need to make this into a rectangle, all I need to do is make it upright. What was that angle measurement? Upright is 90 degrees. So it's a parallelogram with 4 right angles. So let's put in some of the features. Opposite sides are congruent. And something cool about the rectangle is that the diagonals are congruent. Because the diagonals are congruent, it's going to bisect all 4 to become the same measurement. So my key here is the diagonals make 4 congruent segments. But if it was just a parallelogram, it won't be, okay? Okay, for the rhombus, I'm going to start with a parallelogram again. With. All right, hands up and give me a parallelogram. If I want this to be a rhombus, I want to stay slanted, correct? But I want to go ahead and bring it together. So we have with 4 right angles, or 4 congruent sides. I said that wrong. With 4 congruent sides. So we know all sides are congruent too. And I want to go ahead and connect the diagonals. There's something unique about the diagonals. Put a big fat star on this one. Make sure you know all the features about the diagonals in a rhombus. It makes a 90 degrees. It also bisects them. But we know the diagonals are not congruent. And then we know these 2 angles are bisected as well. And notice our tick marks here. So I'm going to summarize 2 things on the right. We have perpendicular diagonals, which is something that we tend to forget. And we know diagonals bisect opposite angles. Perpendicular diagonals, and the diagonals bisect opposite angles. Okay, when you're done, give me a parallelogram. We're going to make this into a square. So not only do I need to make this upright, I also need to shrink it. So 2 things are happening. It is a parallelogram with 4 right angles and 4 congruent sides. And let's connect our diagonals. And I want to emphasize 2 things on this one. It's also perpendicular. And all the 4 pieces from the diagonals being cut will be congruent. So on the bottom 3 questions, it's saying, given a certain amount of statements, what can we conclude about the type of the quadrilateral? So in this case, diagonals are congruent. Then that's going to make this into what shape? If the diagonals are congruent, it's going to give me a rectangle. Okay, with the partner, you decide on, given the following statements, what can I best conclude as the type of quadrilateral? Talk to your neighbor.
Rhombus is the next.
She's taking test.
George, put that away, please. Blake, I think I heard you say the middle one has to be a what? Good job. The third one has to be what shape? Square. Okay, I'm going to give away something that's going to be very, very helpful on always, sometimes, never question. All right, so let's write on the bottom. Always, sometimes, never. And let's write the most specific figure. What is the most specific figure that we went over today? Square. Square? So let's write square. Abbreviate if you need to. If you can spell it out, by all means, go for it. And then I want you to put, next to the square, we have a rectangle. To the right of it, we have a rhombus. And everything on this unit is a quadrilateral. And today we're looking at special parallelograms, so let's write parallelogram. What I did was I put parallel symbolic notation and wrote ogram. If you have another abbreviation, go for it. It's just made up by me. All right, so here's how we are going to use this for always, sometimes, never. Y'all ready? Yeah. All right, watch this. This rectangle, is that always, sometimes, or never a parallelogram? Always, because all of the rectangle is within the parallelogram. Okay? What about a quadrilateral? Is a quadrilateral always a square? Every quadrilateral has to be a square no matter what? That will be sometimes. So if it's partially covered, it is sometimes. If it's all of it, it's going to be a rhombus. Are we clear on that? So I want you to share two always, sometimes, never question from the figure given with the neighbor. Two.
A square always.
Okay. A square is always a quadrilateral.
Make it super quick. Thank you.
What a way to end up doing that.
Rectangle is sometimes. No, it's never.
Never? Never.
A rectangle never a square.
Rectangle is always a square. Not always. Square is always a rectangle. Rectangle is sometimes.
Told you.
I just like the way you said the word never. Never.
Yep, I was correct.
All right, I want to go on to example number 2. I'm going on to example number 2. We're almost done. All right, it says given a rhombus XWVT. Are we behaving while I'm recording? All right. It says our given angle measurement. So we have XTZ, this angle right here, is 5A minus 5. And then here we have VZT, which is this angle right here. Just going to point at it. Because it is a rhombus, what do I know about the diagonals? It makes a 90 degrees. So what I can do is, okay, we could find A or B first. Does it really matter? What do you want to find first? A? Okay. So for the A, we know 14A plus 20 must equal 90. When I subtract 20 on both sides, what do I get? 70? So we have 14A is equal to 70. And I believe 14 can go cleanly into 70, right? How many? 5. So now we can find angle TXV. So the measurement of angle TXV. And we know TXV is right here. So can we find what the angles are and then subtract it from 180 basically? Let's fill in and figure out what is this angle right here. So if I plug in 5, 5 times 5 is how many?
25.
And then 25 minus 5 is 20. So if that angle is 20 and I have 90 degrees, the other angle has to be 70. Because our total angle measurement in a right triangle, or any triangle, must be 180. Now let's find the B. What do I know about the opposite sides in a rhombus? They are Uh-oh. They're equivalent. So 3b plus 4 is equal to 13b minus 9. So I think I'm going to subtract 3 on both sides to get 10b. Add 9 on both sides and get what? 13? So if I take 13 divided by 10, is that going to give me a decimal number? 1.3. And if you have to type it in, that's okay. So we know xt. Xt is part of this right here. So 3 times 3 point, or 1.3 plus 4. How many would that give me? 3.9, and then now I add 4? 7.9. Okay, let's fill in the following theorems. And I'm going to read it out loud as you guys write them down. The first one, a parallelogram is a rhombus if and only if the diagonals are perpendicular. We are basically describing the figure. Anderson writing. Second bullet point, a parallelogram is a rhombus if and only if the diagonals bisect a pair of opposite angles. Third one, a parallelogram is a rectangle if and only if the diagonals are congruent. The fourth point, a quadrilateral is a rhombus if and only if it has 4 congruent sides. And then my last one. Will you pass this over? A quadrilateral is a rectangle if and only if it has 4 right angles. Monica needs one.
I think she already has.
She already has one? Okay, never mind. You're good.
Yeah.
I'll take it back.
Yeah.
I'm working too hard. All right. Let's put a star around all 5 statements. Okay, for the chart. Y'all ready for the chart?
Yeah.
I'm going to model the first one. I'm going to model. If it is true, you put a check. If it is not true, you put an X mark.
All right.
So let's see. Parallelogram has 4 sides. Is that true?
Yes.
Does a parallelogram have opposite sides that are parallel?
Yes.
True? All right, finish it with a partner.
I think parallelogram is all. Yo, give me my sheet.
Okay, I go somewhere.
Bless you.
They bisect each other.
I don't think. What if it's sometimes?
Then don't.
Okay, we got it.
Only if it's true.
You do the other chart.
Next for the last one.
Wait. Diagonal sides, like opposite angles.
How he died. True.
We don't.
2x, x.
Chase.
What?